All right. Vincent, can you hear me? I didn't see all the things I normally do. Okay, Vincent, can you hear me yet? Oh, wait. Well, no, I think. Vincent, I got you here, but I can't hear you yet. Okay. I don't know if I'm making sound or not. Can you tell me? Vincent, please say something. Okay, Vince is still connecting to audio. Yes. Okay, Vince, are you here yet? Vince is still connecting to audio. I hope I'm using the audio from the computer. I don't know that for sure, but I hope so. So, Vincent, can you hear me yet? I can't tell yet. Yeah. Vincent, can you hear me yet? Still connecting to audio. I can't tell if I'm connected to audio is a problem until I can hear from you. And we're recording all this. Vincent, come in, please. I can't tell if you're there. I mean, I know you're there. I can see you on the screen. I can't see you, but I can see that your Vincent's iPhone is listed. So I know you're out there. But I just need to know whether you can hear me or not. Okay. Are you there? Vincent? Yes. I can hear you. Can you hear me? Okay. Yeah. I've got to see if I'm as loud as I can be too, but. Because I normally can hear you louder than this. You usually can hear me louder than this? Okay. Okay. Well, I can hear you, but I am happy to hear you, but I hate to say it this way, but I'm more happy about something else. Did you see I guess you saw the email that I sent. Did you read it? Yeah, I read it. Where you were saying that you were running off the hotspot, and it wasn't really that you were like forward. Okay. Well, here's the deal now. As of the end of my last class, I was still using my wife's iPad because that was the only thing we could do that connected to the her hotspot, and it was really lousy, but it was the best we had. Well, on the her iPad, I couldn't do PowerPoint. Of course, in this class there aren't any PowerPoints. I couldn't get on Blackboard. I couldn't do much of anything. I was just really limited, but we had class, and what I would do was hold my, I'd work on a problem, and if a student couldn't follow it, I'd hold the problem up in front of the camera and let the student see what the camera, and that was what we did. Couldn't record, couldn't do anything. I went downstairs. I had 20 minutes between classes. I went downstairs, and my wife was sitting in there, and she said, "Guess what?" I said, "What?" internet just came back. We had been out since Monday morning at 11:20. And that's why I couldn't have class on Monday, because suddenly we had no internet. And she hadn't set up her hotspot yet. And, and we hadn't figured out a way that I could do it yet. We started using her hotspot with that other computer, and it was not ever good. It would be in and out, even when I was in the same room where her cell iPhone was, which is what the hotspot was in. So it was really, really shaky, and it would go out, in and out, blah, blah. So about the time we were celebrating the internet being back, because she was then having to come up, when I was teaching, come up into the bedroom, our master bedroom, and try not to listen to me. She put on headphones, whatever, but that's the only way she could work on her computer, because she had to be near the hotspot too. She had to bring her phone upstairs. So anyway, we were celebrating that when we heard something bang at the front door. And she said, did something fall? Or could it be a package? Went out to the front stoop. There was UPS driving away. They brought the adapter. They brought the battery. And I've been rushing like crazy to get everything installed. I'm back on the computer, back on Screencast-O-Matic. I can write on my screen again. See this? Look at that. Can you see that? Oh, it's nothing there except a scribble. That's such good news. I mean, we hadn't had hardly any good news all week long. All the news was bad, bad, bad. Finally, we got everything back today. I mean, it happened within 20 minutes, okay, that the internet came back, the package arrived, I got the computer set up, and it has not gone this long without losing power. So I hope it is that strip. I put the new battery in. The battery light's out. So, it's not red anymore. Everything looks like good news now. So we're back like we used to be. And I'm back recording again. So I can't remember where we left off. You were here last time. Well, last time we didn't have class because we lost internet. Okay? But the last time we were here, which was last Wednesday, you were here, and we got in chapter 4, higher order differential equations, 4.3, homogeneous or homogeneous is how I think it's pronounced, linear equations with constant coefficients. And we're ready to go. But before we do that, how are things with you? Okay, I heard good, but I missed the last part. Right.
But it's a whole lot of I guess Zoom meetings and stuff like that I'm gonna be having to join and all this stuff. So it's just I'm trying to. I hate doing it like this, and this is an adjustment for me as far as retrieving my information. I'm just being able to, kind of call and go up there and ask questions like that. It's kind of weird doing it all. Especially like we just came from a bad storm, so that kind of like set me back again. But I'm doing okay.
Okay.
Like I said, I've just got to.
Yeah.
A lot of stuff I got to do.
Yeah, and like you said, a big transition time, and then to have all this going on at a big transition time just makes it more frustrating, because you're going in uncharted waters, but we're all in uncharted waters, and there's just no roadmap for it, So,
I know for a fact that I got while I was doing course evaluations. I think I did Dr. Brian's earlier, and then I'm gonna knock yours out because I know those will be something that I'll forget to do. But yeah, it's kind of weird. Like I had a schedule like months ago with like all of my deadline dates, everything, and so now because of this, all of those dates have now changed, and stuff has been extended out and all this stuff. So I'm trying to get all that. I need to figure out who I
Right.
So I got a lot of little different stuff I got to figure out. But other than that,
Yeah. Are you graduating this term?
yes.
Okay. You've done all your paperwork, right?
For
Lawson
like
graduation.
yeah, as far as I know, to my knowledge, I think I signed up for everything that I was supposed to sign
Okay.
up for.
Yeah. And there's no ceremony this spring, you know. There's no ceremony this spring.
Yeah.
Right. Right. Okay. So I would just, may think about checking in with the registrar's office. It's called the records office now. Just, you might want to email records@lawsonstate.edu and just make sure everything is in order. Let's see. Student course evaluations. We just got an email last night, one of the few emails I got to read before everything shut down. So please do the student course evaluations. I don't know how many courses you're taking, but you won't be taking any classes here this summer. Is that right?
Yeah, I'm all done after this.
Right. Are you planning to take any courses at A&M this summer?
No, I was planning on doing the internship, but it seemed like all the ones that I was trying to do, I got postponed or like canceled for this summer. So that kind of threw another monkey wrench. So I'm kind of in scramble mode trying to find an internship or something too this summer.
Right.
Or a co-op opportunity. Either or is fine with me.
Okay. As far as you know, are they planning to be open in the fall on campus?
I can't even honestly tell you that. That
Yeah.
was kind of one of my questions.
Right. Exactly. So you don't know whether to move or not or what. Yeah.
Yeah, I'm not about to make that move out there because I don't have a job, just waiting on me or anything like that. So it's like that I would just be moving just for the sake of, oh, I hope this opens back up, but I'm not 100% sure right now.
Right.
As far as anything, I don't have anything concrete to
Right.
hold on to, and that's kind of what my issue is.
Right. Do you have a job now, or has that been curtailed because of the outbreak?
Yeah, it's been put to a temporary halt because of the government.
Okay. So whatever you were doing was not counted essential, right?
No, it wasn't.
Okay.
I was serving in bartending, so no, that wasn't counted essential.
Right.
And because at first I was like, well, I could, because it's Hilton. I work for Hilton Garden, so I'm pretty sure I could transfer it to another property that's in Huntsville. But now my property isn't up. Their properties aren't going to be up either. So I really don't know unless I get like something where I'm getting paid by the school, basically.
Right.
Or by somebody. I don't know.
Yeah. I do know that the delivery services are scrambling for employees now, so you might, it's not maybe much of a job, but it would be something to tide over. We're using.
A lot of them, I think, like there's a big influx of people coming in at the same time because a lot of them have like a waiting list.
Oh, really?
Like, yeah, I tried to sign up for a couple of them last week, and they just kind of added me to the waiting list.
Right. Okay. Yeah, it's tough, but I know that we're buying all of our groceries. Well, not quite. When we go to Walmart, they bring them out to the car, and Karen pops the trunk, and they put them in. She brings them home, and then she wipes them all down before she lets me touch anything. So I know that Walmart has people doing shopping in the stores. There's a company called Ship that does grocery shopping for people, and we've used them some. And then what was the other? Oh, the farmer's market. She just places orders and goes picks those up. So and for instance, FedEx, which is not on my good list right now, but the guy I talked with last night who brought a package by, he said he was a contractor. He didn't even work for FedEx. His boss worked for FedEx, and he just had him driving the truck. So I don't know. It sounds like a mess and a half out there. But just keep your cool and keep with it and do what you can. But it's good to hear from you today. And it's so good to be back in the saddle and able to teach like we had been doing way back before my computer died and before the internet died and before all that happened. So here we go. Any questions before we get started?
No, sir.
Okay. Now, if you remember, last time we were talking about, in 4.3, we were talking about, now these are homogeneous or homogeneous linear equations, and we're starting these with constant coefficients, not functional coefficients, constant coefficients. And these are pretty neat things to do. And when you have constant coefficients, you wind up with, and this is just a little bit of review, so because it's been at least a week. I'll go back to page 135 and just remind you. For instance, in a second order differential equation such as this, I haven't been able to write on the screen in weeks, so it's so good. AY double prime plus BY prime plus CY is equal to 0. Now these A's and B's and C's are not functions of X. They're not functions of anything. They're constants. Numbers, 7, 14, pi thirds, 3/4, minus 5/5, 7/5, or whatever. They're numbers, just numbers. And anytime you have a linear ordinary differential equation such as this, higher order differential equation such as this, with constant coefficients, you know automatically your proposed solution is this. Let me write it the same way they do. They just say y. Y is equal to e to the mx. That's how you assume your solution is going to be. And you know that's true because if you take the derivative of that, y prime, that would be m e to the m. Been so long since I've written, I've forgotten how. Okay, e to the mx, and then y double prime, which you have up here, it would be m squared e to the mx. Okay, now these are homogeneous or homogeneous equations, meaning they're equal to 0. That's the key here, because now what we do, if you plug in these things for your y double prime, y prime, and y, you get am squared e to the mx plus b m e to the mx plus c e to the mx is equal to 0. Well, of course, every one of those terms has an e to the mx in it. And if you remember, e to the mx is never, ever, ever equal to 0. So that means we can divide it out. It can't be a factor because it's never equal to 0. So we can just divide it out. Okay? And then what do we have? We have am squared plus bm plus c is equal to 0. Guess what? That's a quadratic equation, standard form. If those were x's in there, they'd look even more familiar. Ax squared plus bx plus c is equal to 0. What we could do is possibly factor that. And if you can factor it, you just plug in your answer. You have m equals something here, m equals something there, and plug those in. Those are your answers. And if that would be called case 1, okay, where m1 and m2 are real and distinct, your solution then would be y is equal to c1 e to the m1x plus c2 e to the m sub 2x. Those are your solution, really easy. Now, if you couldn't factor that, okay, if you could not factor, then you use the quadratic formula. Quadratic formula does like this, just like we used to do it with this. M is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Those are just numbers. A, B, C's are just numbers. Remember, they're constants. Okay. Where you focus your appearance right now is right here on that radical. If that b squared minus 4ac, if that happens to be a positive number, anything greater than 0, then you're going to have a solution just like this, because your M1 is going to be minus b plus the square root of b squared minus 4ac. But that's a real number, because that's greater than 0, you can take the square root. Even if it's not a factor, it's the square root, over 2a. That's just a real number. And M2 is equal to minus b minus the square root of b squared minus 4ac over 2a. Those are just numbers. Plug in the numbers, whatever they turn out to be, as long as that argument there, they call it the discriminant, is greater than 0, there's your answers, and your form is just like that. That's what we covered last time. Okay. Now what we're going to start with today is what they call case 2. Okay? And I'm going to erase all this and then rewrite for case 2. You got it? I may be going too fast. I'm so excited to be back in the saddle. Am I going too fast here? Okay. All right. I haven't heard from Keyston. I hope, yeah, I'm pretty sure I sent them the right. The thing is, did you just happen to check your email, or do you always check it?
I always check my email.
Okay.
So I check it every day because I have a lot of other stuff that I gotta check.
Right.
So that's pretty much
Yeah. Because I guess you realize I usually send these announcements through Blackboard.
Yeah, and I didn't see it, but I also saw that you said
right.
You were having your difficulties from the previous day, which I naturally understood. And so when I saw the email, I was like, oh, okay, sweet. Yeah.
Well, the reason for that is I couldn't. I tried like crazy last night to get those, at least my first class. I got the Zoom invite done. I went to try to put it on Blackboard, and I don't know if you've ever had this happen. Blackboard, when I got so far in Blackboard, all I got was a little circle, multicolored circle, just kept going round and round and round against the black screen, and it kept up that forever. I logged out, logged back in, it was still doing it. And I found out, I called this morning, the Blackboard guru, Dr. James, said, no, Blackboard takes more signal than most things do, and if you're using a hotspot, that's probably not strong enough. So that's why it happened. So I couldn't get into Blackboard to put the invites in. So what we did the invites and then put them, then I had to type in now in this class it was no problem, just 2 names, and I think both of you already had your email address. But the other classes, I had to type in every name on the email and this morning wasn't bad. I had 10 or 11 in my first class, 5 in my second class, 2 in this class, but this afternoon's class, almost 20. Okay, but most of them had been sending me, work, so I had most of them in there too. So I only had to type a few letters, and then their name would pop up. So it wasn't quite as bad as it could have been, but I thought if I'm going to have to do this for all 4 classes tomorrow, this is going to be really terrible. Now I don't have to do it anymore because I can go through just the way we did before. So I'm happy. All right, sorry, I got off on that again. All right, to erase this then?
Yes, sir.
All right, so here's the second case. What if, now everything else was the same, your differential equation was a y double prime plus b y prime plus cy is equal to 0. Linear, second order, constant coefficients. Your what they call the auxiliary equation, exactly the same. AM squared plus bm plus c equals 0. Now, in this one, you could say, go back to your discriminant, and the discriminant now is equal to 0. Guess what? You don't have to do that. This would be, I'll guarantee you, this will be in the form of this. M is equal to minus b over 2a. In other words, your discriminant, the plus or minus b square root of b squared, that's equal to 0. So all you got is a minus b over 2a. This would come if this thing right here happened to be some, I'll just make up some letters now, E, M plus F raised to the second power equals 0. In other words, this only has one real root. One real root, and that real root happens to be minus b over 2a. That's it. Well, you know a second order differential equation has got to have two roots. Okay? So when M1, when your M1 from before is equal to M2, in other words, they're both the same roots. This is M1, it's also M2. You can't write down your solution as M is equal to C1 e to the M1 x plus C2 e to the M2x like we did before, because these two numbers are the same. In fact, that would have been C1 e to the minus b over 2ax plus C2 e to the minus b over 2ax. Guess what? That's not two independent things. You could combine those together and make it C1 plus C2 times e to the minus b over 2ax. That's only one solution. That's not two solutions. Just like the m's are the same. So you don't have two solutions here. You've got to have two solutions. But what we did in the last thing, remember that 4.2, fairly short section, it's called reduction in order. What came out of that was this. Your y2, and I'm not going to go back and redo it all, the y2, the second one, this is your y1 here. I'm just going to make it, rewrite it as y1 is equal to, I'm just going to go back to C1 e to the M1x, just like we did before. But we only have that one solution, okay? Because that's the only solution we got. I just didn't write minus b over 2a. It's too hard to write, okay? But now, by that we did in the last section, 4.2, I guess it was, the y2 is now e to the m1x times the integral. Now, this is coming straight from the book. I don't know if you got your book or not. But that was e to the 2m1x over e to the, it sounds like it's crazy. Yeah, it is. E to the 2m1x dx. If you plugged it back into what we did before, and this is just, it looks like ridiculous to write it this way, e to the m1x, and this is just 1. Integral of dx, and the integral of dx is equal to e to the m1x times x. So how we usually write it then is this. Your general solution, that's your y2. So your y general solution is c1 e to the m1x, that one and only minus b over 2a, that's what it turns out to be, plus c2 times, this time I'm going to put the x in front, x e to the m1x. The e to the m1x is the same, but what happens here is you introduce a factor of x. These two cannot be combined. Those are independent solutions. Even though the M1s are the same, this one doesn't have an X in it, this one does. Independent of each other. The C2s now are arbitrary constant complete. They could be the same, could be different, it doesn't matter. But that's not like it was before, that they just combined to be another constant. That's no longer the case. Now we have it. So, when you have repeated roots, okay, then you just take that root that's repeated, that makes one solution, then multiply that solution by an X, and that gives you your second solution. So that's a pretty easy thing to do too. Case 1, case 2 are both pretty easy. We're still stuck with case 3. Okay? Now case 3 is this one. Your M1 and M2 are complex now. I'm not going to write all the others down, but here's what your M1 is. M1 is equal to minus B plus or minus, well, let's just say M. M plus or minus the square root of B squared minus 4AC all over 2A. But in this case, this thing right here is negative. That's a mess, isn't it? Because then you would have minus B plus or minus I times, and you don't have to do this, but it just turns out being this way. Flip it around and it makes it positive. 4AC minus B squared, okay, over 2A. Now, those are imaginary roots. Your M1 would be minus B plus I times the square root of 4AC AC minus B squared and over 2A, and M2 would be minus B minus I times the square root of 4AC minus B squared over 2A. That's not going to work, okay? In fact, that's going to be really, really miserable, okay? Now, rather than having to write all this stuff down, I'm going to shorten some things here. And here's what I'm going to shorten. I'm going to get the real parts together. That's minus B over 2A. And then I'm going to substitute in a plus. Well, no, I'll keep it this way. Plus, and then I'll put the square root of 4AC minus B squared over 2A. That's times your I, okay? And the M2 will be the same thing here, only with a minus sign. So just to keep from having to write all that stuff all the time, we're going to call this alpha plus I beta, okay? And this one over here then would be alpha minus I beta, okay? That just makes it a lot easier. Remembering that alpha is this thing here and beta is this thing here without the minus sign, okay? All right. Now, that doesn't get a lot better. It just simplifies the way it looks. So now your solution, don't worry, we're not going to use it this way, is going to be, now they go with a capital C1. There's a reason for that. I don't know why they did it, but there is a reason. E to the alpha plus I beta times X, that's your MX, plus C2, capital C this time, E to the alpha minus I beta X, okay? M2X, okay? That's still not very useful. But along comes good old Euler. I don't know if you remember him from earlier classes, but Euler came up with an amazing number of features or characteristics And by the way, I just realized my wife brought my cell phone up because I was carrying all the things to put together my old system again. Okay. I just realized I had no idea of what time it was. I'm getting so excited about having my system back that I'm losing track of time. And let's see, I just looked and now I don't see it. 3:15, we go to 3:45, right? So we got 30 minutes. All right. So here is this form, but we don't want to use that form. That's really awkward. You still have imaginary parts in there, and they're really nasty to work with. But good old Euler came up with a formula, very famous formula, not used that much, but it's a very famous formula, especially among mathematicians. E to the I theta, which is exactly what we've got here, okay, the part of it anyway. So you could write this as C1 e to the alpha x times e to the I beta x, okay, plus C2 e to the alpha x times e to the I minus I beta x, okay? Well, then this e to the I theta, which theta is going to be our beta x's here, this is Euler's formula, is cosine theta plus I times the sine of theta. Well, even if we put that in here and change the so a plus and a minus, you still got I in there. So how is that going to help us any? Well, here's how. I'm going to start erasing at the top and keep what I've got down here at the bottom. Oh, this is I used to hate having to erase. I've been without it so long, it feels so good to be able to erase again. This morning's class, I kept finding myself, and you see here, I was like, no, you can't see here. You can't see what I'm doing, you know. So, using Euler's formula, you got e to the I beta x, this thing right here that I was talking about. We're going to use this here. This would be cosine beta x plus I times the sine of beta x, okay? And e to the minus, this one's here, minus I beta x would be, now, cosine, remember, is an even function. So therefore, minus I beta x is the same as, cosine of minus beta x is the same as cosine beta x. So we don't change this sign. We make this cosine beta x. But then we change the sign of I because I is an odd function. So if you put in a minus there, it is a minus I sine of beta x. Okay. Now, because cosine's even, sine's odd, you keep the sign positive on cosine, but change it to negative on sine. Okay. Now I'm going to do something, and it looks like a sleight of hand, but it is indeed legitimate, legal in every state. So it's nothing that's wrong about it. It just almost is too magical to be true. Okay? And here's what it is. We're going to notice this, that e to the I beta x plus e to the minus I beta x. Okay? In other words, you add these two together, and that would give you 2 cosine beta x. But then when you add these two together, this one and that one, they add to 0. So you get 2 cosine beta x. All right? Well, what happens if you do e to the I beta x minus e to the minus I beta x. Well, you keep this just like it is, and then subtract this one from it. When you subtract that, the cosine becomes minus, the cosines go out, and the signs add, because this changes to a plus, you get 2I sine beta x. And then you say, okay, I like this one because I lost the imaginary part. I don't like this one because it lost the real part and kept the imaginary part. Okay? But it says, and this is the magical part, and I never feel comfortable doing this, but they do it. They say, since this form down here that we had, this form right here, okay, is a solution for our original differential equation, which I've already erased now, for any choice of the constant C1 and C2. What if you choose C1 equals C2 and let it be 1? Okay, that doesn't seem fair, but they did it. And then C1 is equal to 1, but C2 is equal to minus 1. That gives you two possible solutions. Well, one of those, you'll use this one, and one of them, you'll use the, you'll kind of use this one, and again, by magic, it seems like, okay, and there really is they skip so many steps here. It's unbelievable. But what they do, and I'm just going to erase everything else, just because we've lost so many days, I can't go through all the steps here. And frankly, I don't even want to. I mean, they're just that miserable. Just take my word for it, because this is all we ever do. We just use the results. Okay? So I think I'll go and erase all this. And here's what the result is. When you do all the things, all those various steps, so you can, and frankly, you can try to follow in the book, and if you can follow all the steps they skip and figure out what they're doing, more power to you. I want you to come teach me how you did it, because they just skipped way too many steps. So let me just give you the bottom line. But it's true and it works. Here's what your solution is. Y is equal to, now I'll write it in the first way that we don't like. Oh no, it's fine. C1 e to the alpha x. Remember, we had that in there, and that didn't have a real part. That was only, didn't have an imaginary part. That was strictly real part. Times the cosine of your beta x, and remember that already was itself just like that, okay? Plus C2 e to the alpha x. That part stays exactly the same, but now it's just a plain sine beta x. You did magic on those two that had the eyes in them and wound up with no eyes. Now, I hate to say it that way, but that's almost what it seems like, okay? Now, you can pull out the e to the alpha x from both of those, because they both of them have it, okay? And then what you have left is C1 cosine beta x plus C2 sine beta x. So, even though your m's wind up with imaginary pieces to them, your solution has no imaginary in it at all. They're all real numbers. The alpha's real, the beta's real, the c's are real, x's are real, everything's real, and those are your solutions. Now, what you've got to do there, you still do your solutions like you did before with real and imaginary parts to them, but the real part, that's the alpha. The imaginary part, that's the beta, but without the I. Okay? And you put the cosines and sines with them, And there you have it. And sines and cosines are independent of each other, linearly independent of each other, and the e to the alpha x is just a coefficient function that's just there. So, let's do example 1. You ready for it? So tired of the theory, so let's get down to the practical part of doing the solutions. So here's a differential equation. 2y double prime minus 5y prime minus 3y is equal to 0. Okay? It says solve it. Okay? Now, do you want to get involved with how you solve this, or you rather I just keep talking? You'd rather I did? Yeah. Okay. Remember, here's always your first step. When you have constant coefficient, linear, higher order differential equation with constant coefficients, your assumed solution is y is equal to e to the mx. That's always your assumed solution. Okay? Remember that. That's key. All right. Then, by taking, and you don't have to take them, just remember, when you take the derivatives, you get an m in front of the e to the mx for the first derivative and an m squared for the second derivative. So you translate that over here to be 2m squared, because there's your second derivative, e to the mx, minus 5m, because that just had an m in it, e to the mx, minus 3 e to the mx is equal to 0. And then, in fact, if you want to leave off the e to the mx after that point, you can, because they all divide away, because e to the mx is never equal to 0, so it can't be you can factor it out, but it's not equal to 0. It can't be. That means you can divide it out, and you can do that because it's not equal to 0. So here is what they call the auxiliary equation, 2m squared minus 5m minus 3 equals 0. Okay. Now at this point, you've gone back to intermediate algebra. Okay. This is just factoring a quadratic. If you can factor it. Let's see if you can. If you can, the only possible factorization for the first term is going to be 2m times m. Agreed? Okay. Now, you look at the sign of the last term. It's negative. That means these two signs are different. So here's where trial and error comes into play. Let's just pick this to be plus and that to be minus. Let's see if it works. Well, here's another trial and error. The only possible factorization for 3 is 3 and 1. So let's do a 3 here and a 1 there, and let's check it and see if it works. Well, 2m times m is 2m squared. That works. We know it does. Then the outer is minus 2m plus 3m. That's going to be plus m, not minus 5m. So we almost had a happy face, but we don't. So if you got the wrong number, which we did, let's change our numbers. And let's put the 3 over here and the 1 there. So let's swap them out, make the 1 here and the 3 there. All right. Now let's try it again. 2m times m is 2m squared. Outer would be 2m times minus 3 would be minus 6m. And inner would be plus m. And then last would be minus 3. Sure enough, that becomes 2m squared minus 5m minus 3. That one worked by factoring. Yay, we're happy campers. Okay? So what you do with this is all checking it, so I don't need this anymore. That was all checking and make sure my factoring was right. It was. And I really don't need my smiley face anymore, so I'll go and erase him too. So we're happy as also. Okay? Now, what does this mean? If you have two factors that have to equal 0, one of those got to be 0. So either 2m plus 1 is equal to 0, or m minus 3 is equal to 0. And you know how to solve these, right?
Sorry, I just got a message about the paper that.
Okay. Did you say subtract 1 for both sides?
Yes.
Okay, and that gives you 2m is equal to minus 1, and then divide by 2, and you get m is equal to minus 1/2. There is your m1, one of your m's. The other one, just simply add 3 to both sides. And that gives you m, because that adds a 0, is equal to 3. There are your 2 m's. That'll be your m2. So go back into your equation here, and we'll generalize it and make it y in general is equal to the first one, which is C1, always has the arbitrary coefficient, e to the m1, which is minus x over 2, rather than write it 1/2, I wrote x over 2, plus C2, some other arbitrary coefficient, e to the 3x. The other m is 3. There's your solution. Right there, no questions, no problem. Whenever that will factor, you write down your answers, okay? And they're pretty easy, simple answers. Now, even if you didn't factor it, if that came out to be, you know, minus 7 plus the square root of 3, minus 7 minus the square root of 3, that would be your coefficients up here. They're awkward, but they're just numbers, okay? That would be your coefficients. So there's the first one. Y is equal to C1 e to the minus x over 2 plus C2 e to the 3x, okay? I'm going to have to get up for a minute because it's getting a little darker in the afternoon. This room is on the northeast corner of the house, and once the sun moves around to the west side, it's always on the south side, so I don't get any sunlight from the north windows, but from the east windows, there's no more light coming in there. It's getting more shadowy, so I can't see as well. So I had to turn on the light. Sorry about that. So there's your solution. Okay? Now, ready for the B part? Any questions on this one before we leave it? No. Okay. So let's erase all our ink here and go to the B part. The B part is this one. Y double prime minus 10 y prime plus 25y is equal to 0. Again, a second order linear homogeneous differential equation with constant coefficients. Okay? And I'm just for the fun of it going to write it again. Your assumed solution is y is equal to e to the mx. Don't forget that. Remember, that's what your solution is. But you don't have to go through and do all the substitutions again. Calculations for your derivatives. You know what's going to come out of this. This is going to become an m squared. This is your auxiliary solution. Minus 10m plus 25 is equal to 0. Because remember, you could divide out your e to the mx, because that's never equal to 0. Okay? Now, can you factor that one?
This one would be e to the m squared.
Okay? No, okay. M times m. That's the only factorization for m, right? Now, the sign of the last term is a positive. That means these two signs have to be the same. But because the middle sign is negative, that means they both have to be negative. Now, the question here, this is easier than the last one because the last one had a 2 in front. This one doesn't. All you ask yourself now, can you think of two numbers when you multiply them gives you 25 and you add them gives you 10? 5 times m5. Check it and see. M times m is m squared. Minus 5m minus 5m is minus 10m plus 25. And that's equal to 0. So what's your solution for m? M is equal to 5. But it's the same solution. You can't write down y is equal to C1 e to the 5m plus c2 e to the 5m. No, those are the same solutions. So in this case, this was the case that your discriminant was 0. So what we do in this case is simply this. You know that one solution is y1 is equal to c1 e to the 5x, because your m is equal to 5. But the other one, all we do is put a c2 and then just multiply it by x. Whatever the variable is, this happens to be x e to the 5x. There it is. There's your solution. That was case 2. When the discriminant was 0, your two m's are the same, minus b over 2a, or 2m is equal to minus b over a, however the book wants to say it. And what you have, just multiply your known solution, e to the 5x, by x e to the 5x. There's your two independent solutions. Put each one with a arbitrary coefficient. All right. That wasn't too bad either, was it? Now, it is conceivable that you could have had the same thing, but your discriminant is going to be 0. So the minus b over 2a could be a really messy number, a fraction. It could be a radical. It could be anything. Remember, all that's required are these constants. They don't have to be integers. They just have to be constants. So one of them could have been a square root of pi, and you could have some messy coefficients up here, but they're just coefficients. They're just numbers. Okay. So it won't always be easily factorable is what I'm trying to say. So ready for the C part? Okay. All right, here's the C part. Y double prime plus 4y prime plus 7y is equal to 0. Okay? Now, what's your general solution? Not general solution. What's your proposed solution? Y is equal to e to the mx. Remember that, e to the mx. Okay? Now, what is your auxiliary equation then? The algebraic equation that corresponds to this differential equation is that m squared, because that's the second derivative, plus 4 times m, because that's the first derivative, plus 7, no m there because that's the 0th derivative, that's not a derivative, is equal to 0. All right. Now you tell me, do you think we can factor that? Guess what? No, it's not going to factor at all. So then we use the quadratic formula. And how does that go? M is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now what's your a, b, and c in this case? A is equal to the coefficients of your m. A is equal to 1, b is equal to 4, and c is equal to 7. Okay, we just plug those in. Basically, that's your answer. It's just not as simple as it sounds. That's going to be minus a b, so that's a minus 4, plus or minus the square root of that 4 squared, which is 16, minus 4 times the a is 1 and the c is 7. Okay, all divided by 2 times a, well, a is 1, so that's just a 2 down there. Okay, now stretch it on out. Minus 4 plus or minus the square root of 16. Now what I do next is count the number of minus signs. You know you always have one because it's a minus 4. So there's 1, but the other 2 are both pluses. So if it's an odd number of minus signs, that's going to be a minus. Even number of minus signs would have been a plus. This is odd, 1, it's going to be a 1. And then 4 times 7 is 28. Boo hiss over 2. Okay? Guess what? That's going to be a complex number. That's going to be case 3. This is minus 4 plus or minus the square root of, and 16 minus 28 would be minus 12 over 2. Well, we can clean that up a little bit, not much. It's minus 4 plus or minus, okay, is there any hidden, I'm going to string this out a little ways, okay? This is going to be a minus 1 in there. And is there any hidden perfect square in 12? No. Oh, yes. 1 squared is 1. We don't ever use 1. 2 squared is 4. 4 is a factor of 12. So let's factor out of 4. And what do you have left? 3, exactly. Over 2. Okay. So this will be minus 4. I'm really stringing this out. You won't have to do this on most of them. Well, the square root of minus 1 is your I. Okay? The square root of 4 is a 2. So I'm going to put the 2 in front. And the square root of 3 you can't do anything with. So that's just going to be square root of 3. Okay? And this is all divided by 2. Well, guess what? 2 will go into minus 4 minus 2 times. 2 will go into 2 1 time. So your answer is minus 2 plus or minus I root 3. Okay? Now I want to remind you of something. The form that we had before was alpha plus or minus I beta. So what's your alpha in this case?
Your alpha in this case would be the
-2. -2. And what's your beta in this case? Yeah, the square root of 3, because the i's are separate. Those are both real numbers. So, if you remember what the general form for case 3 was, I'll write it down again for you. It's at the top of page 137 before this. That was y is equal to, whenever this discriminant turns out negative, which it did, the general form is, I'll write it the way they ultimately do, e to the alpha x times c1 cosine beta x plus c2 sine beta x. Okay? If you remember that, then you can write down your general solution here to be e to the alpha is minus 2x. See it? And then c1 cosine, and your beta is root 3x plus c2 sine. Same beta, root 3x. There you have it. There's your general solution. So carry that, quadratic formula all the way. When you see it's going to wind up being a minus there, then split that, carry it, break it down as far as you can. You might wind up with fractions here sometime. This could have been a minus 2/3, and this is over 3. If that's the case, then this would have been a e to the minus 2/3 x cosine root 3 over 3 x plus c2 sine root 3 over 3x. Keep the fractional form in there if you need to. Ours just didn't have the fractional form, so I just threw that in for illustrative purposes, just in case you ever do. Don't think you've done something wrong. You could have fractions in there. Okay? You already know you have irrational numbers in there. You could have anything, you just won't have any i's in there. You lose the i's. And there's your solution. Does that make sense?
Yes.
All right. Now, example 2 is an initial value problem, and it's not going to be too awfully difficult to do The only problem is we have 1 minute left, and we're not going to be able to do it in a minute. Okay? So we didn't really get too far today because I spent so much time jubilating over having my old system back. So we'll start with example 2 next time. Let's see if there's any homework exercises I can do for you. I mean, I won't do for you, you can do for me. You can do any of the odds. I think you can do any of the odds 1 through 13. Okay? Oh yeah, we'll stop there because those are all quadratics. We haven't done the higher orders yet. So we'll get to those later. Okay? And then we will move on from there. All right, any questions?
No, sir.
Okay. Now, for the first time in a long time, I'll be saving this to YouTube. I'll be deleting the YouTube that was most similar to this, but all the YouTubes that were in between when I couldn't record, I'll leave those in there. They're going to be at the top of the YouTube list. The new ones that we've done this term are going to be at the bottom of the YouTube list. So anything that's missing at the bottom, you should be able to find at the top. Now, I may miss an example or two, and some of them may have overlap here or there. But in general, they should pretty much fill most of the gaps. Okay?
Okay.
All right. I hope you have a good, safe weekend. You got plenty to work on. Let's see. I believe you've still got well, both of you still have a research paper due. You've already turned in test 1 and 2. And we'll be getting test 3 within a couple of weeks, okay? That'll be your final exam, by the way, and that'll be covering chapter 4 because we've missed so many classes, it's going to be hard to get. We won't finish chapter 4, I promise you, but hopefully you'll get enough that you can build on it and go on from there if you ever need it. Generally, you're not going to need this much detail in most of your engineering courses, but you'll need to have a general idea. All right, well, good deal. It's good to be back in the saddle, and let me go on and end my recording.